Okay, awesome. And yeah, and thanks a lot for attending the my session. And actually, yes, last year I presented our data platform, internal data platform, and the platform or the project name calling the Goku. A lot of people are interested in this naming, and but this year I want to present some new change or new effort and based on this data platform. And we are migrating or moving to the public cloud. I think we start this journey from middle of last year, and the leadership made the decision. And until now, you can think about 1 year period. But during this 1 year, and we did a lot of research, we did a lot of POC or technical design. I think for this conference, I really want to take this opportunity to share what the benefit or motivation for us to move to the public cloud, what the technical problem we try to resolve. And also very important thing that I want to share some practice or some experience we have gotten. And hopefully next year, and when we finish the migration, I have the opportunity to present again and share more best practice. Okay, yeah, I know Sandeep has introduced me, but I will introduce myself again. And my name is Lei Gao, and I joined the workday actually as a data scientist or machine learning engineer. So in my early stage of my career, I really working on the consumer side of the data platform and building the machine learning models or data ETL pipelines. Afterwards, and I moved to the data platform or foundation or tooling side, and now it's leading the team of build internal data science analytics platform. We provide different analytics solutions for the internal users, and we build some data access layer or something, and really make sure at Workday every engineer, every people can leverage data and access to the data very easily. So here is today's agenda. And at first, I will do a quick and go through the current data platform in the data center. And last year, I presented something, just in case someone potentially have never seen it. And I will go through the platform and the technique now we have. And then I will list several challenges or problems and we experience. Definitely this motivation, we move to the public cloud. And afterwards, I will talk about when we move into the public cloud, what are our expectations, what are the technical goal or even the business goals we set up, and to evaluate the migration. And the last thing I want to share, the journey, and we are just several months. You can think about really the technical part is like 6 months or 8 months. And we learned a lot of things, but definitely I know maybe it's not the best practice, but I think it's worth sharing and potentially we can discuss. And if you have a better idea or you have like a best practice, definitely and talk with me and I will be happy to learn. Yeah, before talking about the technical part, I have a quick introduction to the company. And Workday and is a leading provider of enterprise cloud application for finance, HR, and planning. Yeah, and we are the cloud provision for the enterprise company softwares. So for our team, our organization, and was a business problem we try to resolve, and even not only our organization, because we provide the tool, but we are really providing the data platform for the internal users, and most of the data are operational data. You can think about the logs and the stats or metrics, and this really operational data. But the benefits of the business value of this data side we use is really like optimize our cloud service. You can think about it. We use our data to improve the performance, and we use our data to improve the user engagement. A lot of things we try to make sure to deliver and the world-class and best world-class and the cloud service for our customers. Definitely data is very essential components. And during this journey, and definitely I believe that most of the data scientists or even the PM, and they will fit into 3 pillars. And either they do some descriptive analytics, building the dashboards and run queries, answer the business question. or even some people do some diagnostic analytics, and they find the performance issue and they deep in and find, okay, what's the root cause and how to improve it in the future. And even we do some predictive analytics. It's really like a very typical capacity planning and the volume prediction, a lot of things. And this is generally how the company use these logs and the operational data to optimize our cloud services. And then talk about our data platform. And we are a team, a really big team, and our neighbor team and working on the data platform and really on the data lake part. We are working on the data serving and part. So I have a quick introduction to the data lake. And since now we have like 19 petabytes of data in over the last several years and accumulated. But I believe that the number should be much higher than 19, potentially 20 or 20 something. And we have the data velocity is like we have the 2 trillion message and are ingested through Kafka per month. And generally this is the volume, a lot of message or data and ingested to our data lake. And we have like, we use the tables. We have over 740 tables. I believe that now it should be 800 tables, and really a lot of tables and in the data platform. If you look at this, really the serious data lake and how we can make sure every most of the engineers or employees at Workday, either from the engineering department or from the business department, can very easily to leverage this data, make the business decision. It's really a big challenge how we serve the data to the user. This is actually our team's pillar, and to serve our users using the data. This one is our architecture in the data center now. And you can think about it, we are really the analytics tooling side and serving parts. If you look at our in-house tool, I will have a quick demo, show how it works together and share one use case. But you can see really in our platform, the core component that we call the flow engine, Goku flow engine. You can think about it, it's really like the orchestration and the coordination and even some workflow integration engine. And it will be in charge of building the ETL or even machine learning pipelines, and also be used to integrate with Workday stack. When I talk Workday stack, it's not a Workday core services. It's really integration with Workday tooling side. For example, integrating with Jira's or Confluence, Slack, email, a lot of these internal services, and we integrate them together. So user can really build a workflow automated. And the flow engine, we built it on top of the Mesos. And I know Mesos potentially is a little bit out of the picture in the tech world now, but considering that we made the decision 5 years ago and finally we pick up or choose the Mesos, yeah, definitely since now we are still using it very well, but in the public cloud, potentially we will consider Kubernetes or other technologies. But we build our distributed orchestration engine based on the Mesos cluster, and the Mesos will have the different agents talk with either the running environment and the query engine, Flink streaming framework. On top of it, we build the software. It has the job scheduler. It has a DSL parser. It's our own programming language to build a pipeline, and people can very easily write several lines of code and build a beautiful data pipelines. And the last one, we have the flow of code editors. I will show the detail, and definitely there's a UI on top of it. And across this Goku flow engine, we have different tools, and we leverage open source and a community a lot. And for example, the notebook, we use Zeppelin, and the Nimbus, we build it based on the Super side, and RCO Connect, H2O, and the data catalog, we built it based on the Amazon from the Lyft. But the very important thing for this one is that all these tools are built around this flow engine. As I mentioned, it's not a orchestration, it's really like a workflow engine. So we build all this open source tool and they integrate with the flow, so all the tool can be connected. I will show one example how it is used. A quick demo and for the for one of the scenario use case, so people maybe can very easily understand how the flow engine and other open source tool are connected with each other. So here is a use case, and you can think about this use case is very typical and happen every day and in each organization. A lot of PM or engineers, they want to build the dashboards, and also they want to automate the dashboard, the refresh weekly or monthly. Very typical or simple requirements. See how the Goku can meet the requirements. If you come here, this is our in-house tool, Flow Engine, and it has a project concept. So it has a naming space concept. People can create a project, organize your flow and the code into different workspace. And for example, in this demo working space, and firstly, people can go to the code builder and write the scripts and online version. And you can create the file. For example, it support multiple language. And for example, you can create a Python or some scripts and using the code builder. And afterwards, and I have for this demo, I have two scripts. One is the SQL, and another one is Python. Simple enough. For this SQL, it's a very typical SQL query: pull the data, grab the data, do some aggregation. But for this Python ones, and it's really like the integration engine. It can be used to further transformation or cleaning or some work. But most important thing that if you look at the code and the write report, this is our API. It can automatically ingest the result to the dashboards for the visualization. So this is the thing I really mentioned, how we can integrate with a different tool across the flow engine. So here, yeah, I will not go through one line by line about the code, but it really highlight the Goku context. It's really like a lot of abstraction and layer and provided by the API. And also very important thing that we integrate with our Git and repo at Workday, and people can easily do the version control. And I think it's a very important requirement by serious and machine learning projects. And now you will see there are two flow engines. One is a DSL. It's proactively building the pipeline, and another one is UI-based flow. It's drag and drop flow engine. So for this demo, and I will pick up the UI one because it's very, based on our experience, it's one of definitely the more popular and flow engine. And here you can see people can choose what the running environment for your step, and you can pick up the scripts, and we just write in the code builder and specify this is the Spark. And for the second step, we use Python, the same. And you pick up the running environment, you pick up the scripts. And the very important thing that you just click them and it will be connected. It supports the sequential or fork or join any complex and the flow engine. And also it has the environment variables, and you can set up the global flow variables. You can set up a step variables. And also very important thing that because we use methods, and you can allocate the results for each step, and you can configure how much results actually used to run the flow, run the step. Yeah, it's really some other functionality. You can rename or edit your flow again, and you can schedule your flow to run in different frequency. And yeah, so this is a weekly engine scheduler, and also you can directly and trigger the flow to run. Yeah, definitely I will right now. There will be a progress bar to show the status, but most important thing that you can debug your flow online, and you can check the status and debug what's happening and behind the scene. Okay, and afterward, when the flow completed, and you will get an email and say your flow is running successfully. Just check I have whether how much time I have. Yeah, when you get the flow running successfully, you will get a notification. Then you can directly jump to the super site and build the dashboards, and based on the data, automatically ingest it. I will skip a lot of things about Nimbus because about the super side, because I feel that a lot of people are familiar with this very popular open source visualization engine. But the beauty of this integration is that when you build the flow, use the flow to build the ETL pipeline to drive your dashboards, and all the things is automatically. And when you build the dashboards and you schedule your flow to run automatically, and every time or every week, your dashboard will be refreshed automatically. So this is really what we mean the integration. We really highly integrate with the open source project with our flow engine, make sure all the workflow of things can be automated. Sorry. And yeah, but I know sometimes and it looks great, but the challenge is that always we have the challenges. And then I will talk about what challenge we try to resolve. And when we build this platform, and we have 3 different challenges we try to resolve. One is the scaling and the reliabilities. And if you look at our tooling side, the platform is not so big, but we still have a lot of scaling capability or reliability issue. And one of the reasons is that we need to deal with a lot of infrastructure. We need to deal with a lot of running environments and allocating resources, a lot of these things. So it makes the running environment of the team and spend a lot of time on the operational work. And the second, the challenge is the cost. And you know, the cost is major, how to optimize the results, and when we have the peak time, and how we can allocate enough results and for this work. And the last one is usabilities. We try our best to integrate with the tools, different tools together, but still it's fragmented. And a lot of people need to jump around the tools, and they give the suggestion or pinpointed, can we have a single stop and we can do everything? And at least 80% of the work can be covered in the single tool. To address this challenge, and we start to think about the journey and moving to the public cloud. And for our team, and it's not only our team, but the whole organization has some observing the trend in the industry and the data mesh. I believe that yesterday the workshop, and there's a really good workshop talking about the data mesh. A lot of companies are talking about this thing, and this is our solution and how we leverage the data mesh and in our new cloud and data platform. And here, the blue one is really one of our pillar and the service we try to provide it. And we try to provide some domain agnostic service, data service, like the microservices. For the rest of the team, the domain experts, they will build a dashboard and reporting application, or even publishing some data sites. We try to serve this one and provide these services before we really provide the analytic solutions. If you look at the flow, the super side, a lot of things we call it analytic solution. It's a UI, and people can do the work there. But we got a lot of requirements that, oh yeah, we have our own tooling and we have our own requirements, and can you provide the query service and the metadata as a REST API, so we can very easily integrate or grab and access to the data and from our tooling side. So this is the reason we provide also very try to our best to provide the REST API as another very important feature, the user interface. And then people can very easily to access to different microservice or data services and through the REST API. They are not highly tighted by these solutions we provided. And going a little deeper, and that one is really high level, see the data mesh and in the public cloud, what our belief on it in it. And here is really like a deeper and look at how we can implement it, right? And we have the data lake, and we have a different data side. We have stats, log, metrics, aggregated data. And based on this data lake, we try to provide different services. And in our backend, we call the data microservice, or any name. For example, we have the data access service or data access layer, and people can access to the data using a unified view. And we still have the flow service and our flow engine, and can provide the ETL or orchestration capabilities. And also we try to provide the metadata service, and it's really like the data itself, the schema, the lineage, and also very important thing is that the data assets, and around the data, the dashboard and popular dashboard queries, the data assets, and definitely the authentication service is a security model. On top of it, the people can get access through the REST API. And also we have a bunch of the analytic solution and out of the box. And for example, we have the data catalog, still the visualization engine, the flow console, notebook, and even people can bring their own computing engine, and they can use the REST API to access all the microservices on the backend. So this is, I think, super important that can meet the requirements. Either some people and PM, they just want to get the question answered immediately. They can use the visualization engine or notebook. But for some domain experts, they really want to build their application or their tool based on the data, and they can use the REST API to access to the data. Then, yeah, we set up this goal. This really, we try to build the data mesh, the microservice, domain agnostic service. Different words describe the goal, but what the journey. And during this journey, and we can think about, several things when we move to the public cloud. And so for my team or my organization, the first one is definitely we need to migrate the existing data assets or data to the public cloud, very essential. And the second one is we need to fully customize or integrate with open source, even some cloud services, because we need to put them together and become a tooling for Workday. And we are not building a generic tool for the industry. We are building really something Workday needed. And the last one, but not least, is modernization. And we build a lot of tools and stuff, and based on our infrastructure before, and we are limited by the security and the infrastructure and the platform. And by moving to the public cloud, we have more choice and we have more freedom to pick up the latest technology. Definitely, the platform modernization will be a very important dimension. So I will share several examples about on each dimension or each category. For example, one modernization thing I share is we building data access services. And this one is really interesting. And because before we have multiple data sources, we have logs and metrics and even some more business data. Each data has its own metadata and view or access interface, and some through the JDBC, some through the REST API. And the people, the pain points is that firstly, they need jump across different tools to understand how to get access to the data. And the second one is that they spend a lot of time trying to merge or join the different data sets together. So this data access service is really important, and essential is that we try to provide a unified and view to all the users, and they can very secured and access to all the data sets, join, query, and running some stuff. And it's super complex because it across the different data sources, a lot of things. But we list several requirements from our users or customers, and they really try to see what the data access layer can achieve. And firstly, we have two personas. One is we call the data viewers or data analysts, and they build the query and build the dashboard and answer the business question. This is what their requirements. And when they look at this data access service, firstly, they need a standard SQL interface, and most of the data analysts or engineer can write SQL query. They really love it, and they really want using the single SQL query to access to all the data sets. And this I meant another requirement is really like multiple data sources, and including the logs, stats, and operational data, even the business data. And they can use a single interface to access all the data source. And the next one is interactive performance, because for this persona, and they really want access to the data and building the dashboard. So they are prefer to some interactive performance. And the last one is the query and the reporting. A lot of requirements, they want to build a single stop, and they can query and report. And another persona, and we call the data engineers or domain experts. And their requirements is a little bit different, but very interesting. And for example, they prefer to start accessing to the data anywhere because they have potentially accessing the data from their VPC in the public cloud, or even they want access to the data from their IDE for the development work purpose. Yeah, definitely access anywhere, and it's very important. And the second is remove a lot of complexity. This is really the API come from, and we need to provide a lot of API to hide the complexity of the different data source or different location and query something. A self-service model and a lot of like the ETL or something service and should be the self-service. They don't need to depend on our team or other team and become a bottleneck. And the interoperable is really like all the data sites or domain silo can be interactive with each other. This is also very important thing. And look at another example. What we are proposing is customization. And as I mentioned earlier, and the customization, the goal is really provide the deep integration, make sure people have a smooth experience and using the single tool size. One example is the super site. The super site has been used dramatically at Workday as a visualization engine and building the dashboard and look for the performance or other purpose. But the challenge when people leverage the super site is that firstly, they really want to have some optimize the flow engine or data pipeline engine behind the scene. And users, they don't want to build the ETL by themselves. They want to write the query and do some transformation, and someone can help them optimize their query and do some data appending or accumulating, make sure the dashboards can be refreshed automatically. So what we did is that we will integrate and the super site with the flow engine. Now we have integrated. It will automatically ingest data for the visualization. But the requirements is that people want to really build from the UI side. They can create the flow, they can schedule the flow, they can build the dashboard, and from there, they don't want to jump to the flow engine and write a bunch of code. So definitely one of the requirements of customization is that we will build a UI from the super side and really trigger the data pipeline or ETL and behind the scene. But under whose the flow will be backend, the flow backend will be integrated with this UI, and people can very easily to schedule or trigger or ETL pipeline from the UI side. And another this is another requirement also in the super side. If you have to use the super side, there is a component calling the SQL lab. And you can think about it's really the SQL editor, and it has some basic metadata. And for example, if you click, you can see the partition, you can see the schema, you can see some basic metadata. But a lot of metadata and people really want to see like who is the data owner and what the most popular query for this table, what the most popular dashboards and for this query for this table. And we have the Amazon as our data catalog and provide the metadata hub. So what we want to provide is also the deep integration and between the super site and Amazon. And people can using the SQL lab from the UI, we will provide another UI or interface or even the form. And people can very easily pull and the other metadata and in the same UI. So they get the enriched metadata from the SQL lab. They can grab all the metadata information from the same UI. But before it's really, they need to jump to the data catalog and to look at more detail and then jump back to the super site to build the right query. So it's really a challenge and a painful point. And another one is about migration. Migration is pretty straightforward, and we need the migration is really challenging. That is a long tail and effort, and we need to migrate some data to the public cloud. That's pretty straightforward and simple, but one important thing that we need to migrate the metadata. And because, for example, the data, when we do the migration, actually we do some cleaning and do some transformation or even change the data format for the users, and they really want to keep the consistency. So how can keep the metadata consistent and migrating the metadata is actually more challenge and comparing to the data migration. And also for the
Lee, we are running out of time.
Oh, okay. It's 9:20 or 9:10?
9:10.
Oh, sorry. Yeah. I will quickly go through it. And yeah, the last slide, last thing, hiring. Yeah, my team is hiring the one principal engineer and one product manager. And definitely, if you are interested in this product and the fantastic opportunity, you can contact them with my recruiter, Mike, or you can directly ping me. And we're happy to talk and discuss, and potentially you will find a fantastic opportunity there. Yeah, the last one is my LinkedIn. Any questions?